Zeroth law of thermodynamics is a basic law that deals about the thermal equilibrium. So first of all, let me tell you what do you mean by thermal equilibrium. Thermal equilibrium means if one body is in contact with another body physically, heat generally flows from a body of high temperature to a body of low temperature. Heat flows. But if temperatures of these bodies are equal, then there is no flow of heat. Heat flows only when there is a temperature difference between them. If the two bodies are at the same temperature and there is no flow of heat even when the two bodies are connected, then the two bodies are said to be in thermal equilibrium. Now, what is the zeroth law of thermodynamics says is, if we have three bodies, body A, body B, and body C. A, B, C. It says, zeroth law of thermodynamics says, if A and B are in thermal equilibrium with C separately. What's the meaning of that? A is in thermal equilibrium with C. That means even if A is connected with C, there is no flow of heat. When that is possible? That means temperature of the A must be equal to temperature of the C. Then only A and C are in thermal equilibrium. And it is being further said, A is in thermal equilibrium with C and separately B is also in thermal equilibrium with C. That means even when B and C are connected, there is no flow of the heat between B and C. When that is possible? That means what? A is in thermal equilibrium with C. That means their two temperatures are equal. Separately, B is in thermal equilibrium with C means temperature of the B equal to temperature of the C. Then it's implied that A and B are also in thermal equilibrium. See, it's obvious that Tc and Tc is the right hand side of these two equations. So their left hand sides are equal. That means temperature of A equal to temperature of the B. That law is called zeroth law of thermodynamics. So zeroth law of thermodynamics says if A and B are in thermal equilibrium with C separately, it's implied that A and B are also in thermal equilibrium. Now, when you are listening to this, it may appear like very simple for you. What is the big deal there? It is very simple. That's anyway obvious. It's like we know that these two temperatures A and B are in thermal equilibrium. C means A and B are also in thermal equilibrium. It's implied, but that's not that simple. It's not that simple. It has taken a very long time to identify this law. That's why it is called as zeroth law. You know why it is called as a zeroth law? First, this is not invented. First, what is invented is first law of thermodynamics. What is that? We will see later. Later, second law is also invented. And then later, this law is invented. When people has invented this late, and they found that this is even more basic in nature, which deals with about thermal equilibrium and temperatures, people thought this shall be given a prior number to this first. But before first, the only number that is available for you is 0. That's why this is called as a zeroth law of thermodynamics. And now, as I am telling you, this is not that obvious that zeroth law of thermodynamics is very simple. I will tell you an example to tell you why it is not obvious. Say, for example, You are having a friend in your hometown. So your ex Y is a friend to you who is in hometown. Now you have moved to a city, say for example, there you got a new friend Z in a new city where you have relocated yourself. So for you, Y is a friend, Z is a friend. That doesn't mean Y and Z are friends. They are not at all known to each other. They are not friends. So you cannot apply the Zeroth law of thermodynamics everywhere and see that. See, I will also tell you one more example to tell you what I mean by that. Say, for example, we are having a magnet, right? This magnet can attract iron. Magnet can also attract some other material, say, for example, copper. Magnet is attracting iron, magnet is attracting copper. That doesn't mean iron and copper attract each other. Iron and copper won't attract each other. Iron and copper won't attract each other. They are not at all related to each other. So, Zeroth law of thermodynamics, what is being said like a simple law, is simple because you know the concept after you know it, right? Before you know it, it is not that simple. It has taken long time to identify. First, even before that law, first law and second law are invented. That's why this law is called as a Zeroth law of thermodynamics. That's it. Thank you for watching.